Kannst du Fanta holen, kurz?
Okay.
All right.
Hey, everyone. GM. Good evening, good afternoon, wherever you are in the world, because this is truly a global hackathon. So feel free to drop in the chat wherever you're watching us from. That's always super interesting to know. But yeah, welcome to one more Black Magic workshop. With us here now, we have Martin from Avalanche Labs, who will take you through how you can build cross-chain application with Avalanche Teleporter. As you know, Avalanche is one of our main sponsors for the hackathon. They're offering $25,000 in bounties. So do not miss out this workshop. It's going to be fun. Take lots of notes. And as always, if you have any questions, feel free to drop them in the chat and we'll go through them. And yeah, with that, Martin, I'll hand it over to you.
Awesome, thank you. Hey everyone, very excited to talk to you guys today about cross-subnet dApps with Teleporter. I'm filling in for my colleague Megan here, but very happy to jump through. So we will start a little bit like with theory, kind of like what we're talking about, why we even need cross-chain communication in the Avalanche ecosystem. And then we're going to do some hands-on. I will show you the Avalanche starter kit and how you can easily build, isolated cross-chain dApps, and then also deploy them to the Fuji testnet where all the Chainlink services are available, so you can build cool stuff with Chainlink and subnets and Avalanche. All right, let's start. So first, before we start, I just want to give you a quick primer on blockchain performance metrics, right? Like when we talk about blockchains, there are different metrics, right? Like we want to talk about decentralization, we want to talk about all kinds of things, but we also want to talk about performance. And what does performance mean? Performance means that like how much can the blockchain actually process? And we can take this analogy of a highway here. And if you think of a highway, then each of the cars on that highway is a transaction, right? Like, so if you do whatever, you do a transfer, you do a swap, you do anything on chain, think of your transaction as being a car, right? And when you hit send in your wallet, right, the car enters the highway. And when you see this notification that tells you your transaction has been successfully submitted to the chain, then it exits the highway. So really this car is just on the highway for a short time. And now we can characterize this highway with two metrics. The one is throughput and the one is time to finality. So time to finality means how long does it take from you click send to your transaction is recorded irreversibly on chain, so it can never, be undone. You can be 100% sure that what you just did really happened. And the other one is throughput, meaning how many cars can enter the highway at the same time. And you can see already here in the picture, these metrics are not related, right? Like, so you can have a very long highway, that takes a long time, but only has a single lane or many lanes. And at the same time, you can have a short highway with many lanes or a single lane, right? So what we want to do here is we want to build the optimal highway. So let's say we have two cities we want to connect. We want to build, like a highway with like multiple lanes that has a short time to finality, the shortest time that's possible, and still a high throughput, so we don't get into traffic jams or anything like that. What we want to avoid is, like a long time to finality. So a highway that takes a massive detour is only a single lane. So, there's easily congestion and it takes unnecessary routes, right? Like here, like going through Paris, if you want to go between Munich and Berlin. So what are Avalanche subnets? Avalanche subnets are designed in a way that they have a high throughput, around 2,000 transactions per second, but a low time to finality. So your car will only spend like a second on this highway. Ethereum is much longer, right? Like you have 15 minutes finality. And there's a throughput that's better than Bitcoin, but still very limited. So we have to come up with all kinds of things like layer 2s or something. And Bitcoin is really like this single lane highway, very, very low transactions per second. I believe it's 7. And, like a very, very long time to finality. So you have to wait many, many block confirmations until you can be really sure that your transaction is confirmed on the Bitcoin network. So as you can see already, I mean, this is good. Avalanche subnets are cool, but this single highway won't do anything for us, right? Like this is really just the beginning. if we think about, like bringing many people on chain, many of the business processes we know today, this highway won't be enough. So one thing we can think about now is, think about how can we build bigger and bigger highways. And it turns out that's actually very hard to do at some point, right? Like if you have a 20-lane highway, it's going to get very, very hard to add 20 more to it. And what we believe at Avalanche is that we will need, like highways 1,000 lanes. So we're doing a little trick here. Instead of, like pushing the one highway further and further, we're working with subnets. So what does that mean? Maybe you're familiar already with the Avalanche primary network, right? Like that's a C chain if you ever used it. That is like one highway that's validated by all the validators of the Avalanche network. But now we're doing a little trick that we are adding another highway that's only validated by a subset of the validators, right? And we call that a subnet. So we can keep doing that actually and do it over and over again. And these validator sets may overlap, but it's always only a subset of the Avalanche validators. And what you can see here now is we have multiple highways in parallel that are independent, that remain the short time to finality. So you click send and the transaction is immediately confirmed, but you have a massive combined throughput, right? Like, so it's like instead of building like one very large highway, you have like many highways in parallel. So you can, like get many people from A to B just on different highways. So as you can see here, it's a very effective scaling approach. All of these highways are layer ones. They are not settling anywhere. There's no bottleneck. You can like indefinitely, scale further and further by just adding more highways. It's a super straightforward approach. So, but now we have one challenge we have to solve. And I'd argue every blockchain has to solve for it, but we have to solve for it really well. And that's interoperability, right? Like no ecosystem alone can offer everything. Doesn't matter if you're on Ethereum or on Avalanche or on a subnet in Avalanche, there will always be services or liquidity you want to access from other ecosystems. So we will have to solve for interoperability. How do I get from one highway to another highway? And we have a very elegant version of this within the Avalanche ecosystem, Teleporter. And maybe you're familiar with CCIP of Chainlink, right? Like that's another elegant version, how to get from Ethereum to the Avalanche C chain or to Polygon or wherever, right? So we're going to look now in this presentation how we can get from one highway to another to access liquidity, but also services, right? So one big bootstrapping problems of blockchains when they launch is, like how do I get, like all these amazing services, Chainlink functions, pricing oracles, interoperability protocols to my blockchain. And it turns out if you launch a highway in the Avalanche ecosystem with your application on it, there's a pretty easy way where you can access it. And this will be heavily, targeted in our hackathon bounties. The idea here is how we can access the interoperability protocol of Avalanche to make these services like Chainlink, pricing oracles, Chainlink functions, CCIP, available to other highways, to other subnets on the Avalanche ecosystem. So let's think what happens here. So cross-chain communication is really, the primitive of it is just sending a message from one chain to another. So a source chain is sending a message to a destination chain. There's nothing else that happens here, right? Like a message can be anything, just bytes. And it turns out if I can send bytes from chain to chain, I can do everything. I can do asset bridging. I can send price oracles. I can do all kinds of things. So what we have to solve for is sending simple messages. And usually this message is something, like that some kind of event occurred on the source chain. So for example, with asset bridging, if you want to bridge an asset, what it is, you send it to a bridge contract, you deposit it with a bridge contract, and that bridge contract then sends a message to the destination chain. And you get a bridge token on the other side representing the right to claim the original token on the source chain, right? Nothing else happens in bridging. It's just a simple message about the tokens can, not really cross the borders of blockchains. It's always just a message that something has either been deposited or burned in another chain, and therefore you have the right to receive a new token on the destination chain. So we can do asset bridging, we can do DAO voting, we can do cross-chain liquidity pools. We can, make services available, all kinds of things. If we can solve for this little thing of sending messages back and forth. And now I want to talk about Teleporter. And there is, like a whole primitive below it called Avalanche Warp Messaging. There's interesting stuff happening. I'm skipping this stuff for today. So if you're interested in what happens under the hood, I recommend checking out Avalanche Academy. There's a course called Cross Subnet Dapps with Teleporter. You can learn about the cryptography, how it's secure, how there's no trusted third party, all this kind of amazing stuff. Today, we're just going to look at from the side of the developer, right? So at a high level, you can see here, right, like under the hood, there's happening a lot. But you as a developer, you're writing a cross subnet dApp, and you have one on the source chain and one on the destination chain. You interact with Teleporter. Then some magic happens with a warp precompile, an AWM relayer, Teleporter. So lots of stuff is happening here. The beautiful thing about Teleporter is you don't really have to worry about all that stuff. You only have to solve for two things. You have to tell Teleporter what kind of message you want to send, and then you want to have your cross subnet dApp on the destination chain being able to receive that message. Everything else is abstracted away from you. Everything else just works magically. All right. So these are the two components. These are the two building blocks we have to solve for here. All right. And we're going to look at what that means. And then we're going to have some hands-on demo of how we can do this stuff. OK, so let's look at how we can send a message. And it turns out it's just a very simple smart contract call. So all we have to do is import Teleporter Messenger into our smart contract, and then call the send cross-chain message function here. And you can see that there are, like some inputs, like which chain do I want to send it to? Which smart contract on that chain do I want the address sent the address to? And there's some optional stuff like fees and everything. You can ignore it for now. You can set the required gas limit of the action you want to do on the destination chain. And the last thing, line 11, is really the important thing. You just put any message in there, and the message is just bytes. So you can literally send any message from your source chain to the destination chain. What you encode in this message doesn't matter. It can be a message about, like you are depositing some tokens. It can be a DAO vote. It can be anything you can imagine. So it's a really primitive messaging protocol that really enables you to do anything between these two chains. So we've sent the message now, right? We called that function. The message is on its way. The relayer will do its magic. So what happens on the destination chain? You can see here, right, like this interface, iTeleporter receiver, is all we have to implement in our cross subnet dApp, right? So it has only a single function. It's like, if you may be familiar with JavaScript, you can think of it as a callback, right? Like, so you kind of define this function, and when a message is delivered to you on the destination chain, it will be called. You know where it's coming from, the chain. You know which smart contract on the chain send it to you, so you can make sure, for example, that not a malicious contract is sending you a message about a token deposit, but only the bridge contract on the other side. And you can see here the bytes in line 9, the bytes of the message. So you can unpack that and, like decipher whatever it says. So this is really the base primitive here for Teleporter. And we can do some amazing stuff with it, right? Like, so, for example, we can, like sum up numbers and everything. So I just want to show you guys real quick one thing. So if you think about how to get started with Teleporter, right, there's some dependencies and everything. So let me just share a different tab here. So to make it super straightforward to get started with, oh yeah, there we go. Cool. To get started with the development of Avalanche and Teleporter, we created this starter kit here, right? I'm just going to drop the link in the chat. So you can see here, this is the Avalanche starter kit, and it has everything you need for developing with Teleporter. So it has Avalanche CLI, Foundry, Teleporter, AWM relayer, and some examples in the contracts. So the really powerful thing about this starter kit is you don't have to install anything. You can literally run it from your browser. So all you have to do is click on code here, and then usually, you might know this screen, but switch over to the code space tab, and I have already some running. You should see a big, large green button called Run Code Space on Main. If you already have some, there's another plus here. But if you have that, just click that one, and then the code space will actually open in another tab, and it will look very, very familiar to something like this. Let me just check that. Yeah. So if you're familiar with Visual Studio Code, you might know this interface. So this is a browser version of Visual Studio Code. And yeah, so the Avalanche Starter Kit will be run, all the dependencies will be installed, and you have everything here in this one environment, so you can play around with it. So if you want, follow along, go to the Avalanche Starter Kit GitHub, click on the green code button, switch to the code spaces, and then click on the create code space on main. And then after, I think, 1 or 2 minutes, you should see something like this. And now I just want to take you a little bit through, like, okay, like how can we build with Avalanche? So one important thing for Avalanche is Avalanche CLI. So Avalanche CLI will enable you to run local networks. You know, these are great for testing. You don't have to worry about tokens. You know, you're basically a billionaire on these local networks. It also includes Foundry. So if you're familiar with Foundry, that's a smart contract tool chain. You know, lets you compile and deploy and call these contracts. It has all the teleporter dependencies and has an instance of the AWM relayer, and it has many example contracts that are collected here in the source folder, right? So before we look into the examples, let's just look at basic usage of Avalanche CLI. So what you can do here is you can just type Avalanche and you can look at the help menu. So this will already give you a lot of information about the available commands. So if we now wanted to create our own highway for our own blockchain, what we can do next is we can do Avalanche Subnet create, and then give our subnet a name. I'm going to call it my subnet, and let me zoom in here a little bit so you guys can see it better. And let me see if there are any questions so far. I don't see any. Okay. So you can see here, Avalanche Subnet create, my subnet. And this dialog will take us through some questions here, right? So the first question is, what kind of VM should our subnet run? And we're going to select subnet EVM, because everything we're doing in this hackathon is EVM-based, so Solidity and EVM-based. Avalanche itself is virtual machine agnostic, so you could also have a Solana VM or a Move VM or whatever you want to build. You can do that. You can also have special purpose virtual machines, but for this hackathon, let's just focus on the EVM. We're going to use the latest version of the EVM, and now it asks us if we want to enable teleporter. Yes, we do. So we have the interoperability, AWM relayer, just go with the same, and choose a chain ID. I usually choose 4 nines. Since we're on the local network, you can use whatever chain ID you want to do, and we're only doing testing. So now it asks us for a token symbol. So one thing I didn't tell you yet about highways is each highway has their own gas token. So this is actually one of the super powerful things of Avalanche. So imagine that. You can launch a blockchain where you pay gas in your own token. That means you don't have to buy ETH, you don't have to buy AVAX, you don't have to buy any other token. And this token, this highway, is completely isolated from the other highways. So if there's an, like a NFT drop happening on the C chain, or a bull market happening on Ethereum, right? Like usually the fees go up. Something that cost you 50 cents today might cost you, like $10 tomorrow. If you have your own highway with your own token, nothing of that applies. So super powerful. We get some control over how we want to set the fees for our chain, but we can just ignore that. And I'm going to select the second option here to airdrop 1 million tokens to the default address. We call it the EVOC address we use for testing. There's already the note here, do not use in production. Since we're only testing today, that's totally fine. All right, so now we're just airdropping 1 million of these tokens that we can use to pay for gas to our wallet here, to the default wallet, and then we can play around with it. And now it asks us about precompiles. We can ignore this one. And okay, so we created our subnet configuration. Let me check if there are any question or no, nothing so far. Okay. So you can see now that we created the subnet configuration. So now we can deploy it on our local network. So the next command we want to go with is Avalanche Subnet deploy. Deploy, and then the name of your subnet. I called mine my subnet. I recommend doing the same for the ease of debugging. And now it asks us, okay, where do you want to deploy your subnet that you just created the configuration for? We can do it on the local network. We can do it on the Fuji testnet, the mainnet, or create a devnet for it. We're going to use local network today. So now it's deploying the blockchain. Let's just wait a minute here. And now it's also deploying teleporter messenger to my subnet, the registry, and the token symbol. So as you can see now, our blockchain has been deployed. We have the RPC endpoints, everything we need in the command output. So yeah, this is really, really powerful actually. And now we can start building, right? So what I want to show you today is how to simply send one message from the Avalanche C chain of our local network here. So everything lives right like in this online development environment. It's completely separate from the mainnet. It's completely separate from the testnet. It has its own kind of like it's its own set of highways we are building here, right? So let's look into the first example here, the send and the receive example. And actually, we have some instructions here for every example. So if you do this, you can also follow along. And the first thing we got to do is we got to find out the blockchain ID of our subnet. Now, if you remember, when we send messages, we have to specify where should we send the message to. So first thing we have to find out is kind of like what is the unique identifier of our blockchain that we just created. And we can do this with Avalanche Subnet described. Avalanche Subnet described, then the name of the subnet. So that's my subnet. All right. So you can see here tons of information on our subnet. And what I need is the local network blockchain ID in the hex format. So there's also another format. Please use the hex format. All right. And now we can put this in the sender contract. So right, like we have one contract sending, calling the send cross-chain message function, and one that's the receiver. And this one, I'll just give me a sec. The receiver. That's the one that's implementing the iTeleporter receiver and the receive teleporter message. So I have to tell my sender, where should I send this message? So I have to paste my blockchain ID of the subnet that I just created. I also put a comment here so you know where to put the destination blockchain ID. And yeah, this is actually it from the changes to the code we have to do. So as you can see here, in the sender contract, we just instantiate the teleporter messenger. And then in this function, send message, we're doing a very simple thing. We just call it with some parameters that we already saw in the presentation. And then we're just sending the message over. And in the receiver side, on the receiver side, we are just implementing the receive teleporter message with the different parameters. And then we are just storing the message in a variable. So we have this public variable, public string, last message here. All right, so let's see that we get back to the instructions. So we replace the blockchain ID in the sender contract. And now we want to deploy the contracts. So if you're not familiar with Foundry, Foundry comes with a set of commands, and Forge create is the one to deploy contracts. So we are putting in, let me do this a little bit larger. So Forge create, we are telling the RPC URL. So what chain are we, what RPC endpoint are we sending the transaction to? We're using the private key. That's a private key we selected for the airdrop. Then the contract, and that's it. Okay, so let's see. Okay, so we see the contract has been successfully deployed. This is the address of the contract, the deploy to. So I will always also have to do this with the receiver contract, right? On the thing. The command is very, very similar. The one difference you can see is that we are deploying it to a different RPC URL, so not the local C chain. Oh, sorry about that. But actually to the my subnet RPC, right? If you didn't use the name my subnet, you have to manually configure this RPC, so highly recommend just using my subnet. Otherwise, you can find some instructions in the README. All right, so let's do the same thing. Let's deploy the receiver contract. So that also worked. That's great. And now we want to send a message. All right. So what we're going to do now is we're going to use this cast, which is basically just calling a transaction on the local C chain with our private key, and then the sender contract address. So that contract we are sending the transaction to, we're going to have the message signature and then the parameters. So the first one for send message is the address, meaning the contract on the destination chain that should receive it, and then the message we are sending. So as you can see here, we're sending it to receiver contract address and then the hello. So the two things I have to change here in the command line is, first I have to change the receiver contract address. So take out this placeholder. The receiver contract, receiver on subnet, has been deployed to this address. Oop. All right. And now, the other placeholder I have to remove is the sender contract address. Okay. All right. So you can see here now that the transaction went through. So we see some metadata. But at the end of the day, we see the transaction. And this means we have called successfully our sender function. And yeah, it looks all good. So you've seen in this demo here a lot of, like some very powerful feature already. Let me just... Okay. Yeah. So you've seen here some super powerful stuff and how easy it is to send messages from one chain to another. So what would we do now? Now we are just sending a string from one chain to another here, but it's important to know that we want to do more powerful things with this, right? Like, so we could now instead of sending a simple hello world, what we could do here, instead of taking this as a parameter, we could put information of a pricing oracle, right? We could say the message should be some price of ETH or something, right? Like all kinds of things, and put that into a message. We can also put multiple values into a single message. So there are a lot of things. What I'd like to recommend is check out this course here in Avalanche Academy. So, there is this, if you go to academy.avex.com, let me just put the link in here in the chat. There's a full course on just what we just talked about the starter kit and everything. You can find it here, Cross Subnet dApps. So this is the Academy page, and this is the course, Cross Subnet dApps with Teleporter. So everything we talked about today, you can find in this course, right? And even more advanced examples. And yeah, so what can we do now, right? Like, so this is only the tip of the iceberg. So if you look at some pretty cool project that has been done already, is this, you might be familiar with Chainlink VRF, the verifiable random function. So one of our engineers actually built a wrapper around the VRF proxy, the Chainlink VRF function with Teleporter, right? So we have the Teleporter, the Chainlink VRF on our Avalanche C chain. And then he built two contracts, VRF provider, VRF proxy, and between it uses Teleporter Messenger to like bring the random value between these two chains. And it's implemented with a simple betting game. So one thing you could do is build on top of that, build a small application on a subnet, running on a subnet, leveraging Chainlink VRF through the through Teleporter, through this project. So I'm also going to put this in the chat here. And this would be definitely one thing that would be pretty cool. You can also check out the contracts in the contracts folder here, and you can see here in the proxy somewhere we're gonna send a cross-chain message, right? So you can really see like how this works and how it can be adapted in another thing. Another cool project that's out there is called CrossSync. So highly recommend checking that out. It was submitted for another hackathon. So this is a protocol basically abstracting away many different interoperability protocols. Maybe you're familiar with Axelar, Hyperlane, Chainlink, CCIP, Wormhole, and now it also puts Teleporter in there. And it's pretty cool because basically you're just talking to one contract in one format, and then you have access to all these different interoperability protocols. And not only one, but actually what you can do now is if you have your own blockchain in the Avalanche ecosystem, your own highway in the set of highways, and you want to set a message to Polygon or Ethereum mainnet, you actually can't do it. There's no direct route. But what these developers did is they built a protocol where you have multi-hops. So you send a message with Teleporter from your subnet to the C chain, and then from there it's sent using CCIP or XLR or whatever to another chain. So that would be also pretty cool to see teams, like build more on this, these kind of ideas. How can we make interoperability seamless? Maybe build on top of this protocol, and how can we, like make even more services that are not even available on the C chain, but somewhere else on some other ecosystem that's just connected through some other interoperability protocol. So I will also drop this in here. Amazing, cool. Then I'm good to go, I think, with this one. So we did a lot of ground covered. I hope I gave you guys some ideas for the hackathon and like the places to go. So in summary, check out Avalanche Academy, check out the Avalanche Starter Kit, and check out these sample protocols around the Subnet VRF or the CrossSync protocol that has been submitted here for ETH Oxford. And then we are super excited to hear like what you guys are coming up with, what you want to build. If you have any questions, feel free to reach out to us or just ask them now if you already know them. Okay. And I think one last thing, if you are curious to do something with token swaps, there is this demo here called Oh My Warp. It's also public, so I'll find the GitHub link in a little bit. So this is kind of like a demo of a token bridge. And one thing I missed before is that with Avalanche Starter Kit, you can't only like test it in local development, but actually also for testnet, right? Like, so obviously if you have a local network, all these Chainlink services, they won't be available, right? Like, because it's a local network, Chainlink doesn't integrate with local networks. But of course they're integrating with the Fuji test network of Avalanche. So what you can check out here is when you're somewhat familiar with Foundry, we already configured the RPC endpoints for the Fuji seed chain. And above that, there's also a subnet called Dispatch. So there are actually two, Dispatch and Echo, who are available on Fuji to test teleporter apps. So there's a relayer, these messages getting automatically delivered between the Fuji seed chain and Dispatch. So everything you have to do is when you follow the instructions for the basic example, for example, you can see here, first we have the stuff for the local network, right? The local network instructions, but a little bit below, we have the Fuji testnet instructions. And there's a little bit more overhead because on Fuji, you have to get testnet tokens in your wallet, right? Like we can't just airdrop ourselves 1 million tokens. But if you go through it and go to the Avalanche faucet, where you can use a coupon code that's also in the README here, then you can, like similar to how we just created the contracts on our local network, but just instead of using local seed, use Fuji seed, and then the transaction will be sent to the RPC URL of the Fuji test network and deployed there. And then you can do the same thing we just did here. And so that will be better if you like build out. So I would say like build the basic primitive in the local network where you can play around, and then as soon as you start integrating services and like take out the mock contracts you might use in the beginning, then you can like move over to the C chain and Fuji C chain and integrate with the services there. Okay. Oh, I see some questions. Where can I find Avalabs dev roles to ask questions? I'm just jumping in here today for my colleague. I believe there should be a Telegram group. Maybe the Chainlink team can help me out finding that link or what has been set up. Can VRF be hacked if there's a delay between consumer on C chain and teleporting to subnet? Very good question. So there are some security considerations, right? I'm not, so definitely check out how the VRF works. I believe it works, but don't quote me on that, but I'm pretty sure it works in a way that, you have a simple betting game. You can find some, where is it? You have a simple betting game. And I believe you do the bet first, so both of the parties commit to their bet, and then the random value is requested, and then the bet is settled after. But you are right, like like with having a delay between the C chain and the thing is, but I think it's similar on a chain itself because like with MEV bots you can front run transactions, so it adds some complexity here, but I believe the measures in place to prevent front running through bots, through other, like MEV bots, are also effective for cross chain. So like you first commit to a bet, and then you are then after only getting the random value. So yeah, you can see here we have these different statuses for a bet, right? We're proposing a bet, we take a bet, and then we complete the bet. And I believe while it is taken, we are just waiting for the so we agreeing on the bet. Let's flip a coin. One wins head, one wins tail, and then we're waiting for the result of the VRF to be delivered. And until then, both our funds are locked. I see another question. Verifying a message received returns an empty string. Yeah, there's a small issue here. Great that you walked through it. There will be a tiny fix to the Avalanche CLI, to the Avalanche starter kit, but it should be fixed in a very short time. So just try that. If you try it with Fuji, it should just work fine. But the local network has a little hiccup right now. Yeah, I think I don't see any. Did you mention the compatible chains already? Laura, I'm not quite sure what you mean. I think if you're thinking about compatible chains, every chain in the Avalanche ecosystem is compatible with this, right? So directly compatible with Teleporter, every chain in the Avalanche ecosystem, through things like protocols like cross-sync. It's not a live protocol, right? Like, so just some hackathon project. You can do with multi-hops, you can get to any other chain. These are signed messages from wallets. Not quite sure what this question means. Yeah, but that was early on. Okay, cool. I think this is everything from my side. So from my side, we can wrap up this session.
Awesome. Thank you so much, Martin. It's awesome to always have Avalanche spending some time with us. And again, yeah, feel free to rewatch this workshop as many times you'd like. And yeah, I think we can wrap it up. Keep building with Avalanche. They have their own Telegram chat for supporting the hacker. So if you have any questions, feel free to go there. And yeah, thanks again, Martin, for taking the time. And we'll see you all tomorrow in our next workshops. And yeah, happy hacking, everyone. And yeah, have a great day. And thanks again, Martin. Have a great day as well.
Thank you.
Yeah.
That's great.
Bye, everyone.
Bye-bye.